Hello and welcome to the lesson on classes and objects. Start off with a little warning. While JavaScript is not a traditional object-oriented programming language, JavaScript is flexible and powerful enough that you can make it act like an object-oriented programming language. So many people argue, is it object-oriented, is it not? I'm saying it's powerful enough to act like an object-oriented programming language. So let's do a lesson on object-oriented programming and discuss classes and objects. Let's look first at a class is to an object. How is a class to an object? A class is to an object like a blueprint is to a house. What do I mean by that? A blueprint is the design of a house. A blueprint is the specifications for building a house. Well, a class is a specification for building an object. Or think about it this way, like a recipe is to a cake. A recipe is a complete set of instructions, a list of ingredients, and the steps to take to make a cake. That's what a recipe is to a cake. It's how to build a cake. Well, that's the relationship between a class and an object. The class is the blueprint for building an object. The class is the recipe for building an object. In JavaScript, we don't have an actual class keyword like we have in languages like Java and C#. In JavaScript, in order to mimic a class, we create a special function that is like a class. So what we're really building here is sort of a Uber function or a modified function that will behave like a class and allow us to build objects. Now, you may not think you're ready for object-oriented programming, but you are. You've already done everything you need to do in order to build a class/object in JavaScript. Can you declare a few variables inside a function? This idea of a local variable, we're going to create some variables inside of a function. Well, if you can do that, you're halfway there. Can you write a few functions inside a function? This is really the only new thing. We have written functions already. You should already know how to build a function. All we're going to do is write functions inside a function. This is critical in order to make JavaScript act like an object-oriented programming language. So all you got to do is write a few variables, which we should know how to do, and write a few functions and make sure they're inside another function, and you've got what you need to build a class/object. We'll use the new operator to create an object from that special function. So is that clear? In JavaScript, we won't actually be building a class. We'll be building a special function, and that function will behave like a class, and we'll be able to use that function to build objects out of it. Here we go. We're going to build a function enemy. In Java or C#, this would be a class enemy. But in JavaScript, we build this special function to build an enemy object. So we're going to build this function enemy with the purpose of creating objects out of it. Now, inside that function enemy, we're going to declare some variables. We're going to use the var keyword and create some variables at the top of the function. These are the variables that will be part of our object that we build out of this special function. Then inside the function, what we're writing here is a function inside of a function. We're going to write functions inside this special function, and they will become the functions or methods of the enemy object. And of course, there's the curly brace that ends the open curly brace of our special function enemy. Everything inside this special function will be part of our object. If you're not inside this function enemy, you won't be part of the objects we build out of that function enemy. At this point, what we have to do is create an object. Here's a simple line of code: object equals new enemy. It's kind of new here. Enemy is a function, but when we say new enemy, it actually builds an object that is very much like the objects we'd build in Java or C#. Again, JavaScript isn't a traditional object-oriented programming. I don't think at the very beginning it was intended to be an object-oriented language, but they realized quickly that you can build these object-like functions and behave like an object-oriented programming language. So as long as it acts like an object-oriented programming language, JavaScript doesn't need to be a full object-oriented programming language. And again, I'm going to teach this lesson from a standpoint of maybe in the future you're going to go on and learn other languages. There's several different ways you can do this in JavaScript, and I'm going to do it in a way that is most like the way you'd program it in Java or C#. Very few programmers learn one programming language and never learn a new programming language. So we're going to learn JavaScript object-oriented programming with an eye towards the future, an eye towards learning other object-oriented languages. That's why I'll use a lot of terminology that might be more appropriate for a full object-oriented language and less appropriate for JavaScript, but I want you to learn the terminology of object-oriented programming. And hopefully, after you learn JavaScript, you'll move on to learn other languages. The other thing I want to stress about objects is they don't exist until you run the program. As a beginner, the first thing you should understand about objects is objects are a runtime entity. If your program is running, you may have an object. If your program is not running, you don't have an object. Objects are runtime entities. They get created while the program is running by a line that looks like this: object equals new enemy. When this line of code executes while the program is running, it builds an object in computer memory. Another way to think of an object is as a sort of a super variable or an uber variable. An object is a variable, and it contains multiple pieces of information. When I create a simple variable like var age equals 21, I'm storing one and only one piece of information in that variable. An object is like a super variable. I can have multiple variables inside of an object. I can have 3, 4, 5, 10 variables inside the object. An object can also have functions or methods. So I can have several variables and several functions inside of one object variable. So there's our gentle introduction to classes and objects. And remember, in JavaScript, classes don't technically exist. We build special functions that build objects in JavaScript. So let's look at writing one of these special functions or classes. Again, I'll be using the terminology class a lot because that is the proper term in object-oriented programming for these things that we're building. Even though technically in JavaScript we're building a function, a special function, it's going to act like a class in another language like Java or C#. So if you find me using the word class instead of special function, please understand, I want you to learn the terminology. We're building a special function, yes, but it's a function that's going to mimic a class in an object-oriented programming environment. So let's build this function enemy. And again, this is a special function that's going to build a class. What you have to focus on here is the curly braces. The curly brace at the start and the curly brace at the end are the boundaries of our class. Anything inside these curly braces will be part of the object that we build out of enemy. If you are not inside these curly braces, you will not be part of the object. Classes/objects have variables. The var in this case is very much required. You have to use var here. We want these to be local variables. We want these to be local variables so they're contained entirely within the object enemy. These are also known as properties. The proper object-oriented term for the variables that are part of the object are called properties. It's an old habit that's hard to break. They look like variables. Exposition, Y position, and health are variables, but when they're part of an object, we want to start using the term properties. And please make sure you use a var when you're declaring the variables. Also, it's not a requirement, but please put these at the top of the function. It's nice when they're in a spot that we can find them readily and quickly. So make sure that you put your variables at the top of your class. Objects also have functions. And let's be clear here. This red box here, notice these functions are entirely inside our special function or class enemy. Inside an enemy, between these curly braces, we're building other functions. Other languages like Java and C#, these are called methods. And method is sort of an object-oriented term which basically says this is a function that's part of an object. Normal functions that aren't part of an object, we call them functions. But take that function and put it inside a class, put it inside of an object, and the object-oriented term for that is a method. Put it simply, a method is a function that is part of an object. There's a term called constructor. Constructors build objects. What I've got here in the red box is the code that will execute when the object is created. When I say object equals new enemy, this code, setting X position to 0, Y position to 0, and health to 100, when the object is first created, this code will run. The code that runs when the object is first created is called a constructor. Constructors typically initialize the variables at the top of the class. This is called a set method, set Exposition. What a setter does is it puts values into objects. Set Exposition will assign a new value to the Exposition variable. Set methods set new values into objects. Next up is get Exposition, also known as a getter method. Getter methods pull values from objects. When somebody outside the object wants to know what the exposition of the object is, they'll call get exposition. Notice how these functions are inside an enemy. That's what makes these methods, that's what makes function enemy a class, or at least a special function that mimics a class. Let's write some code to build an object out of our special function / class. A class creates a new variable type. Function enemy is a variable type at this point. I have a variable of type enemy now. Let's run the code to create an object. Remember, the class is the blueprint for the object. I'm going to use my class enemy right here to build a new object and assign it to the variable object. Do you understand what I'm saying when a class creates a new variable type? We've dealt with number types and string types and even array types at this point. I want you to think of enemy as a new variable type, an object being a variable of type enemy. The var object, remember the var is the declaration part. The var object declares an object reference variable. We're going to call this an object reference variable. Object reference variables point to or refer to actual objects. Now let's go execute the new enemy over here. Remember, the new keyword builds a new object. It says allocate a chunk of memory for the object, run the enemy constructor, and let's build an enemy object. Notice the parentheses here. Notice enemy is followed by 2 parentheses. That means we're calling a function. We're calling enemy here. Notice 2 parentheses, an empty set of parentheses here, an empty set of parentheses here. Go run this enemy special function and build an object out of it. It built the object, it created the X, Y, and health variables, and now we'll execute the code to initialize that object. We're running the enemy constructor, exposition equals 0. We'll put a 0 in our object. Y position equals 0. We'll put a 0 in the Y position variable. I'm assigning a new value to the Y position variable inside the object. And health equals 100. Assigning 100 to the variable health inside the object. Notice how this code is inside the class enemy. It's initializing the variables of class enemy. Once we've initialized the variable, the construction code is done and it will return back to the calling program. Once the enemy object is completely built, this equal sign will assign the enemy object to the reference variable. Now see that line here? It should almost point to this line. What the equal sign is doing is attaching this reference variable to the object that we built. The variable object is a reference to an instance of enemy. We've built a new enemy object, and the reference variable object will allow us to refer to or access the object. Let's use that object. we'll say object.setExposition and pass it an argument of 50. Now the object says go to this object variable. The dot operator says go inside that object variable and run the method setExposition. So it's going to go and run this setExposition for this object. SetExposition will say exposition equals x. X is the 50 that was passed to the parameter x. So the 50 that was passed to the parameter x will be assigned to the exposition variable, and you can see that 50 showed up. Recall that setters put values into objects. Whenever I want to put a new value into one of the object's variables, exposition, y position, health, I should run a set method. Now I didn't have room to show you all the different set methods, but there could be a set y position and a set health, and every time I want to install a new value into an object variable, I should call what's called a setter method. Setter methods put values into object. This one wanted to put 50 into the object, and you can see a 50 showed up here in exposition. That's what setters do. They put new values into the object's variables. Returning to my calling code, I'll drop down to the next line. We'll declare a variable x, a simple variable x. X is not part of an object. X is outside the object, so I'm drawing it outside the object. We've declared the variable x, and now we're going to call object.getExposition. Object.getExposition. Go to the object variable. The dot says follow this reference and go inside the object variable. Inside the object variable, I want to access the method getExposition. So this line of code is going to jump and run getExposition. GetExposition runs, it will simply return the current value stored in the object. Whatever's in exposition, in this case 50, should be sent back to the calling routine. Getters pull values from objects. Getters get a value out of the object. Remember my description of an object as a super variable. Well, look at this variable. It's holding 3 pieces of information: the x coordinate, the y coordinate, and the health of this particular object. So a get method would pull a value out of the object. I did not have room to show it to you, but I would expect a full and complete class would have a get y position, which pulled the current value of y out of the object, and a get health method or function that pulled the current value of health out of it. Getters pull values from objects. Setters put them in, getters pull them out. So I pulled the 50 out of the object, I sent it back to the calling routine, so the value returned is assigned to x. Now let's look at something I didn't highlight earlier, but it's extremely important. Notice the red boxes. This one first, and then this one over here. Functions inside of functions will be local. There is no outside access to them. Recall from these variables, exposition is declared locally inside this function. Exposition exists as part of this enemy function. Well, it's no different for setExposition. This would be a local function inside of it. What this .setExposition equals setExposition does is allows objects outside the function to call the method. That's why I boxed out over here. The only reason object is allowed to run setExposition is this line of code over here. If I left that out, this would be like a local function and I wouldn't be able to call it. So if you have any hopes of calling a method or calling a function within another function, you have to do this line of code. It literally says this object's setExposition function should be set to this setExposition right there. What this does is allows public access to the method setExposition. If you want to call it from outside the object, you're going to have to do that this.setExposition equals setExposition. Now every function or method we want to call with the object, we have to do this for. So here's a second this.getExposition now equals getExposition. What we're going to do is say I want to allow outside access to this function getExposition. This literally means this object's getExposition function should equal this local getExposition. Functions inside of functions will be local. By default, there will be no outside access to a function inside of a function unless you do this dot exposition equals getExposition. This allows the objects, which is code outside the function, to call this method. If I were to delete these two lines, this dot getExposition equals getExposition, this dot setExposition equals setExposition, I would no longer be able to call these functions or methods. Add that for every function you want the user to call, every function you want the object to call. That was a pretty simple class. They'll get more complicated. We are a little limited for space here. I can't put in all the methods. I probably would have added a set Y position and get Y position if I had the room. I would have added a set health and a get health if I had the room. But you can kind of see where this is going. And we'll look a little bit more at setters and getters in a future slide. Constructors. What are constructors? Constructors help build object. Who takes a blueprint and builds a house? A construction worker, of course. What takes a class and builds an object? A constructor method. Now here's where we got to be careful. Java and C# have special methods that are clearly constructor methods. In JavaScript, a constructor is the code at the top of this special function that will execute and initialize the object's variables. Remember, these variables that we declared at the top are our object's variables, and that's what the constructor code does. It initializes those variables. What I've built here is three different classes, enemy 1, enemy 2, and enemy 3. I want to show three different ways to construct. Constructors initialize object variables. Constructors use the parameters of the function to provide values for the object's properties or variables. I also want to learn a little object-oriented terminology here. When it's outside of an object, let's call these things functions. When it's inside of an object, let's call them methods. When it's outside of an object, let's call it a variable. When it's inside of an object, let's call it a property. Variables, or properties if it's inside of an object. Constructors assign initial values to object properties. That's what the constructor code does. It initializes your variables. Now, there are other options. You can pass parameters to the class/function. Not trying to say you should create 3 enemy classes. I'm just showing you 3 different ways to construct an enemy object. This first one is what we call a default constructor. It's a constructor with no parameters that assigns default values to global variables. Most likely you'll need to call set methods to provide real values for the properties after you construct an object this way. It's very unlikely that all enemy objects will start at position 0, 0. It's unlikely. X position 0, Y position 0 means all your enemies are going to show up in the top left corner. If you don't want all your enemies in the top left corner, you're going to have to improve this constructor a little bit. And that's what enemy 2 does. This is an alternative constructor. Let's call this option 2. This allows code creating the object to pass parameters x, y, and h to provide values for those parameters. So instead of always going 0, 0, and 100, I can pass parameters and set my variables to the values of those parameters or arguments. Here's another alternative constructor. Let's call it option 3. We'll allow code creating the object to pass an object or an array as a parameter. That's what A is. It's a parameter to provide values for the properties. So I'll get the values for my X and Y from this array. Getting the picture? When you're building your first classes, when you're building your first objects, you got to decide, do I want to be able to initialize the variables or not? You're going to need parameters if you're going to want to initialize those variables when the objects are built. Let's trace some lines of code that builds actual objects. Different constructors make a big difference when you create objects. We're going to call these different constructors with their different parameters and see how it affects the code. This first line, I'll break it down piece by piece. The first part here is var object1. What we're doing here is we're declaring or creating what we call a reference variable. A reference variable is a variable that will point to or refer to an object. So let's declare that variable first. So go out in computer memory and build object1 in computer memory. Then it'll do the second half. It'll do the new enemy1 here. New enemy1 literally says I want to allocate a new chunk of memory for an object enemy1. Also, see, there's no parameters here. It will call the constructor over here with no parameters and execute the code inside of enemy1. Objects are variables and methods. So you can see the exposition, y position, and health variable are part of the object and they get allocated. Now let's run some code. Let's run the constructor code here and initialize those variables. So exposition will be set to a hard-coded 0, and you can see a 0 showed up in the exposition variable of the object. Y position is equals to 0, and you can see a 0 showed up into the Y position variable of the object. And finally, health equals 100, and you can see that 100 showed up into the health variable of the object. That's what constructors do. They initialize the object's variables. The only problem with this constructor is everybody gets the same X and Y position, and that might not be what we want. After we do the new object, we will assign the object to the object1 variable. We will attach the object1 reference to the object that we just created. That's what the assignment operator does. Say, take that new object and have object1 point to it or refer to it. I almost wish I took that arrow down to this line, because that's what that equal assignment operator does. It assigns this object to that reference variable. Next up on this line, I'm not going to break it down piece by piece. You know it's declaring object2. You know it's building the object. You know it's attaching the reference. I'm just going to do it all at once rather than break it down step by step. Let's focus more on calling the constructor. This new enemy2, I'm going to pass it 3 parameters or 3 arguments. I am going to call the enemy2 constructor with 3 parameters over here. Jump over and execute that code. Exposition equals x. Take the value passed to the parameter x and assign it to the exposition variable. Now normally I draw a line from here to here, but I want to make it clear that this 50 is what's being assigned to exposition. That 50 went through this x variable, and from this x variable it went into the exposition object property. Y position equals y. Again, the user provided 100 as the second argument. The second argument got assigned to the second parameter. So the 100 coming from the y variable got assigned to y position. But it's because of this second parameter that that 100 shows up. Finally, the third argument, 75. The 75 got passed as an argument to h. The parameter h then got assigned to the health variable, and you can see the 75 showed up. It started from this argument, but it showed up as a value in the object's properties, in the object's variable. Now, I myself find that the more useful, to be able to send values in while I'm building the object. I find that more useful. Let's look at a third way to do this. Let's call a constructor with one array parameter. Look at this. I have a single parameter here. I'm sending a single parameter here. This square bracket, remember what the square brackets mean? It means array. I want you to dynamically build me an array with 2 numbers in it, 20 and 30. I could have put in these parentheses, new array 2030. That looks more like an array, but it is not a requirement to use new array. I can just say, hey, dynamically construct me an array with 2 values in it, pass that array to the parameter A. Copy the array element to object 3. See that exposition equals A subscript 0? I'll take the value out of A at subscript 0 and assign it to the exposition variable. See the Y position equals A subscript 1? That says take the value out of subscript 1 or index 1 of the array, pull it out of the array, and assign it to the Y position variable. X and Y is what typically changes between different objects. So I only really need to initialize X and Y. A default value of 100 for health, that's reasonable. Does everyone have to have a different health value at the beginning? Maybe, maybe not. In this case, this example is saying everybody's going to get a health value of 100 at the start of the game. End of story. As soon as you create an enemy object, it gets a health value of 100. So there's my 3 different versions. One that takes no parameters and everybody gets a default value. One that takes 3 parameters and there are no default values, so the user gets to decide. And then this third option using an array, I'll let you change the X and Y position, but I won't let you change the other variables. Note, no overloaded constructors in JavaScript. Other languages might allow you to write 2, 3, 4 different versions of constructors. JavaScript doesn't. We've got to decide if and what parameters to pass the constructor when we're coding it. The reason I included the array example is the array example would be a way to send multiple values as parameters without listing them all out. If you wanted to mimic the idea of an overloaded constructor, you might be using that array example. Class design. So you want to build a class, do you? Well, how do you build a class? How do you think about building a class? Well, classes sort of mimic real-world things. I want to design a class gun to build gun objects. How do I do it? To create a class/object, you need to come up with a set of variables and set of methods, because that's all a class is. Set of variables and set of methods. You need to design a class before you type in the code. When I'm designing a class, I like to write down 2 lists. The first list is what the object is. That's the variables and properties. What piece of information describes this object that I'm going to be building? The second list I like to create is what the object does. That's going to be the functions or methods of the object. If you want your object to jump up and down, you're going to have a jump up and down method. If you want your object to fire a weapon, you're going to have some sort of fire a weapon method. The methods are the actions that the object takes. So let's start building our class gun in order to build gun objects. We'll create our function gun special function with variables and functions inside of it. Now, what is a gun object? What data or information describes a gun? I started thinking about a gun and I thought, well, I want to know the type of gun. I want to know the caliber of the gun. I want to know how much ammo the gun may hold. That's the information that describes what a gun object is. Let's break it down piece by piece. The type of the gun would be something like pistol, rifle, or shotgun. Very important to understand that. Again, this is just a simple video game where your character can fire a gun. We need a gun object to represent that. Next up is the caliber of the gun. What is the round diameter of the barrel of the gun? If there's a decimal point, we're talking about the English system. That's 0.36 of an inch, a 36 caliber gun. 0.45, that's the caliber of the gun. It's a bigger caliber. It's going to fire a bigger bullet. 0.45 indicates we're storing an English measuring system value in the caliber of the gun. What about metric? Some guns have metric diameters of their barrel. The 9mm just needs a 9. I guess you could put a 9.0 on there, but it's not needed. A metric barrel measured as caliber would be a 9. Finally, the ammo count. How much ammo does this gun currently hold? Does it have 15 bullets? Does it have 6 bullets? Does it have even more than that? How much ammo does my gun have left? Certainly want to know that before I pick it up and go after the other players in the game. Now, what doesn't belong in the class design?
What does not belong in this list of things that describe the object that I'm going to build? Well, I'll tell you one thing, int temp. I can always spot students that don't understand object-oriented programming when they declare and use variables like this as object variables. Now, what does temp do to describe what a gun object is? Nothing. It does absolutely nothing to describe the gun object. Var temp should be a local variable in some function. Declare it in a local variable, but don't make it one of the variables at the top of your class. Everything here in the variables at the top of this class directly describe what a gun object is, and that's what you want your variables to be. Variables should be the core information that describes what the object is. If you were to go to buy a new gun, the things you'd want to know are things like what type of gun is it, what is the caliber of the gun, how much ammo can it hold. Variables should describe the core information that describes what the object is. Let's say I was building a car video game and I wanted to build a car. I need to store the make, model, and year of that car. That's critical information for describing a car. Make, model, and year. What if I was designing a book class? Well, the critical information to describe a book is the title of the book, the author of the book, maybe the number of pages of the book. Very important that the variables at the top of your class describe what the object is. Methods. What a gun object does. What actions does a gun perform? If I write down a list of things that I want a gun object to do, I'm designing, or at least starting to design, the methods or the functions that will go inside the class gun. We know we need to create new objects. We need constructors. So we've got to pick out a particular type of constructor. So I went with the simplest one, the one with no parameters. So this code will execute. This constructor code will execute as soon as the program is running. And you can see it's doing what constructors do. It's initializing the object's variables. Next up, I have a fire method. That one seems obvious to me. Why have a gun unless you intend to fire it? Again, this is a video game gun. It might be shooting water balloons for all we know. But we're going to fire our weapon, and that's what guns do. That's why it belongs as a method of the gun class. The methods describe the actions that a gun object performs. We also want to be able to reload our gun. If we pick up new ammo, we want to put it in and reload our weapon. The list of things the object is defines the variables of the class. Go back to my var temp variable. That doesn't describe a gun. We need the information that describes what a gun object is declared at the top of the gun class. The list of things that the object does defines the methods you want to write. What does a gun object do? Well, we want to be able to create new gun objects, so we need some sort of constructor code. We want to be able to fire the gun, so we need a method to do that. And we want to be able to reload the gun, so we need a method to do that. Also recall the this.reload equals reload. That is so outsiders, people that are using the gun object, can call that method. Primitive versus reference types. Woo, what is this? Variables come in two flavors. Primitive types are not objects. Number, character, boolean, those aren't objects. They take a small amount of memory and you store the values directly in the variables. Reference types are objects. We've looked at string now, an array, an enemy, and gun. These are all things that I intend to make objects out of. Memory is allocated for the reference and the object. Let's trace some code and see how the different types of variables are dealt with. We're going to declare var score. Score is a number. Takes 8 bytes of memory in JavaScript, and it's going to have an undefined initial value. If you declare the variable only and don't assign it a value, it's going to be what's declared undefined. Now, if this was a local variable inside a function, it would be allocated when the function runs. If this is a global variable declared at the top of your program, it would be allocated when the program runs. Var money. Again, we're declaring a variable money,
Money is a number. We intend it to be a floating point number, but it's the same 8 bytes of memory. And again, it will have an undefined initial value. Money currently does not contain a value. If it was local, it would be allocated when the function runs that contains this variable. If it's global, it's allocated when the program runs or when the web page is loaded. Integer and double are both technically stored as floating point in JavaScript. JavaScript makes no difference between an integer variable and a number variable. You're all just numbers to JavaScript. Var rank equals b. Rank is some sort of string variable. How many bytes of memory will take? Hard to tell. It depends on how big a string I assign to rank. No doubt, though, in this case, the initial value is b. When we first set up the variable, we gave it the initial value, so it's got to have a value of b. Strings can also be objects. This is one of the things that confuses even me after all these years. In JavaScript, apparently, strings are a data type and they can be objects. It can be both. So we'll just create the first kind, a string data type here. And we'll look down below how we make sure that we create a string object. Score equals 100. I'm just showing you what I can do with a score variable here. Assign the value 100 to the score variable. Values are stored directly into primitive data types. Money equals 24.50. Assign the value 24.50 to the money variable. Values are stored directly in primitive variables. All I did is create or declare a couple variables and then put some values in it. I'm hoping you're starting to visualize not only how the code runs, but how the data gets allocated in the machine. Now let's look at reference variables. Reference variables will be objects at some point. Declare a var name. String is a class. Name is a reference. Reference variables allocate, I'm thinking 8 bytes of memory. It might be slightly different, but let's go with 8 for now. The initial value of undefined indicates the object has not been created yet. Name equals new string, passing it Mario. Assigning a value to the name reference variable using new allocates memory for an object, then connects or points the reference to the object. Look clearly here. Mario is not stored in the name variable. Mario is stored in an object. The location of the object is stored in the name variable. Var monster, the enemy class. The enemy is a class. Monster is a reference. Reference variables allocate usually 8 bytes of memory. All I'm doing here is declaring a variable. I am not building an object yet. Monster equals new enemy and pass it 20, 40, and 50. Assigning a value to the monster reference variable allocates memory for an object, then connects or points the reference to the object. The values 20, 40, and 50 are arguments, and they are not stored in the variable monster. The location of an object is stored in the monster, and once I have a reference to monster, I can run the constructor method that assigns values to Exposition, Y position, and health. Notice the 3 different parameter numbers to create an object. String uses 1 parameter, Mario. Enemy uses 3 parameters or arguments, 20, 40, and 50. And gun is using 0 arguments or 0 parameters. Declare and assign an object to the weapon reference variable. Allocates memory for both the reference and the object, then connects or points the reference to the object. Values are default from the gun class constructor shown in a previous slide. I do not have to do this in separate steps. I don't have to declare var name and then set name to an object. I don't have to declare var monster and then set monster to an object. I can do it all in one line of code. I'm going to call var weapon equals new gun. I'm going to go run the gun constructor for this class, and let's see how it works. It's going to set the type to pistol, the caliber to 45, and the ammo count to 6. Are you seeing the difference between primitive and reference types? Reference types refer to the object. Primitive types store the values. Primitive types like number, boolean, and undefined are small fixed amount of memory, values stored directly in a variable. Reference types need memory for the variable and for the object. The value in a reference points to or refers to the object in memory. Public versus private. JavaScript does not directly support declaring variables private or public, but it is also powerful enough to sort of mimic that behavior. In other languages, the keywords public and private specify the access mode of a variable or method from outside the class. If it's declared private, I'm saying no outsiders can access it. If I declare it public, it means all my users can access it. Public means everyone should be able to access this element. Anyone can call the public methods setYear and getYear in this example. Private means very restricted access. No one outside the class can directly access the private year variable. JavaScript does not use the keywords public and private. It uses the this dot strategy. This dot some element equals this other element. That's what makes it public. It's this line of code that makes getYear public. It's this line of code that makes setYear public. Otherwise, if you leave it off, it defaults to private. So if I lost this line of code, I can no longer call getYear from outside the class. Usually the class defaults to public access. Classes have public access. This allows others to build objects from the class. So I'm going to say var object equals new car and build an object out of my special function or class. This would be code that executes from outside the class or function car. And the question becomes, what elements inside the class or function car will the variable outside the class be able to access? Let's run some code and see how it works. First of all, I'm going to declare my var year in such a way that it's private. So when I build my new var object equals new car, I'm not going to allow direct access to my private variables. Notice where these arrows point to. I'm not allowed to do this because this is a private variable. I'm not allowed to do this because that is a private variable. Over on the other side, private means the code inside the class car can directly access year. This code setYear can access year because it's part of the same class that owns year. This getYear can access year because it's part of the same class that owns year. It's important to realize what you have access to and what you don't have access to when building classes this way. Tracing the code, we'll say var object equals new car. There is my object being built down here. I went ahead and assigned it to the object reference variable just so we're sure what it is. We're going to try to execute object.year equals -2. This is very bad. It looks like it is accessing the year property, but it's not. And you do not want to do it. -2 is a bogus value. No car was built in the year -2. What would make this line of code work? How could I execute object.year and assign it a new value? If I did a this.year equals year inside the class, this line of code inside the class, somewhere here, like between these two functions, would allow others in. Here's the proper way to change the year inside of an object. I'm going to say object.setYear and pass it the argument of 2016. 2016 will be assigned to the YR variable. By calling a public method, setYear can request to change the private year variable. We're passing it the argument 2016 and assigning it to the YR variable. Look what happens. We'll go inside the method and start executing the method. SetYear is what we call a setter. It's a method designed to change the value of a private variable. Notice how a proper setter verifies the input. I'm going to make sure that YR is good before I do the assignment. Well, 2016 greater than 1900, well, that's a true statement. It was built at 1900 or later. 2016 is less than 2025. I wanted to put an upper limit on it so nobody tried to say, well, this is a car from the year 2030 or this is a car from the year 3047. I want to reject years like that. I want to keep these cars recent.
Now, since this is a true statement, what's going to happen? It's going to fall in and execute this code, year equals YR. And that's the purpose of a setter. The purpose of a setter is to protect your data, to protect your variables, and only allow a set method to change them. Don't allow other programs to change it. Since the input parameter YR was a good value, the setter goes ahead and changes the value of private variable year. Inside the class, we have full access to year. A good setter will verify that the value you're trying to change year to is a good value. In this case, since my car is between 1900 and 2025, we will accept that year parameter. Back to the calling code. We're going to say the year equals object.year. Again, this is an error. This is an example of something you cannot do. Think of this access mode of this global variables as being private. It means code outside the class cannot directly access the value in the year variable. This will not, I repeat, will not execute or access the 2016 stored in the property year. See that 2016 right there? This command will not be able to grab that out of that and send it back. What would make it work? How do I get a line of code like this to work? When I put it in my code, this.year equals year. That will make it work right. Back to the calling code. Let's execute the next line of code. The year equals object.getYear. By calling a public method getYear, you can request the value of a private year variable. I'm going to go in and execute this code in getYear. Let's see what it does. It returns year. The 2016 that was returned is assigned to the year variable right there. The return value is a copy of what was stored in the private variable year. Get methods pull values out of objects. Set methods push values into objects. Finally, let's call setYear with a bad value. To show you how private guards the value stored in an object, call setYear with a bogus argument. The -2 was sent over to setYear. -2 greater than or equal to 1900 is done. Once this portion is false, it really doesn't matter whether that's true. And means they're both supposed to be true. So if you know one isn't true, then we can fall through and execute this code. What happened here is instead of executing the if portion, we're going to go to the else portion. When we go to the else portion, we're going to execute a console.log. Notice the -2 was not assigned to the year. Instead, the code inputs bad year -2. To inform the caller, -2 is not a valid car year. Get and set pattern. There is a get and set pattern to these things. I want to go through this slide quickly and show you what the get and set pattern is. A pattern is something that repeats itself. Variables private and methods public is a pattern. Get and set methods, getters and setters, follow a clear pattern. To show the pattern, I will display get and set methods for each variable. Since that will take too much space, I'll only show one at a time. Set methods. We want a set and a get method for the make variable. Every variable should have a set and get method. Set methods insert data into objects. They also have a name pattern. It's the word set followed by the variable name with an uppercase first letter. So if the variable's make, we'll call the set method setMake with a big M. If the variable is make, we'll call the getter method getMake with a big M in make. It's just so we can spot the method and kind of tell where it comes from. Set methods always have input parameters. Set methods are trying to put something into the object, so MK will come through this parameter and will then make its way out to the make. Get methods have an output or return value. Get methods always send something back. GetMake is going to return the current value of the make variable. Setters put stuff in, getters pull stuff out. So in a set method, the pattern is this. Assign the input parameter to the private variable. Whatever you send setMake as a parameter, assign it to the global variable make. Get methods return the value of the private variable. Send back the value of make to the caller. Here's some new code. I'm now looking at this variable model. If I have a object variable name model, I want to write a set model and a get model that allow me to change the values or access the values stored inside the object. Get methods pull data from objects. The name pattern for that is get and the variable name with an uppercase first letter. Now, are you seeing the pattern? All I really changed from set make and set model is the name. All I really changed between get make and get model is the same. Once again, its set method has an input parameter, and it's going to assign that input parameter to the properties of the model object. Get methods have an output or return value, so get model is going to send something back. The pattern holds. Model is a string. Set model has a string input. Get model has a string output. Again, it's a pattern. Set methods assign the input parameter to the private variable. This code is doing almost exactly what the previous code is doing. Get methods return the value of the private variable. Get model is returning back exactly what is stored in the model variable. Set model follows the pattern for set make. Get model follows the pattern for get make. New code, new type. We're now looking closely at the cost object variable. Here's our set method. Insert data into objects. Follows the name pattern. Set methods have an input parameter, the same type as the variable it is setting. Get methods have an output or return type, the same as the variable it's getting. The pattern holds. Cost is a number, so set cost has a number input. Once you know the pattern, writing more get and set methods is easy. Code generators can easily write them for you. Just add better input checking in set methods. Think of objects as mega variables. They can store multiple pieces of information, and set methods can put values into those. Get methods then pull those values out of the object.